Here are solutions to homework set number 2 for ECE 376. The first problem is assembler commands. Assuming the working register W and 2 spots of memory A and B contain this initial value, what happens after each instruction? The first one says increment B, put the result in W, so 13 goes to 14. The second one is decrement A, put the result in A, so 12 goes to 11. Inclusive OR A with W. So A is 11, W is 14, OR them together. If either bit's a 1, the answer is 1, so I get 15. So 15 goes to W. Do a logical AND B with W. So W is 15, B is 3. That clears out the high 4 bits, leaves the 4 bits alone. So the answer is 13. 13 and 15 is 13. Move 15 to W. No change. Subtract W from A, put the result in W. So 11 minus 15, so this is A, that's W. Subtract W from A, I get minus 4. You can also write 252. Both numbers are the same, that's 2's complement. Number 2. Convert the following C code to assembly. So when I declare my variables, that just means I have to assign 3 spots in memory since these are 8-bit variables. Then to implement this, a couple ways of doing it. One is I move 3 to W, then add B to W. That gives the B plus 3. Add C to W, add C again, gives you 2 times C. Take the result, move W to A. One solution, there's many others. That's an 8-bit operation. Problem 3 is the same problem, but now using 16 bits. And that gets kind of harder because if I have like A and A plus 1, I've got 16 bits, so this is the high 8 bits, here's the low 8 bits. When I add two numbers together, I have to add the low byte, then add with carry the high byte. So to start out, move the number 3 to A, so 3 becomes 0, 3. Move, I guess I did it this way. That's kind of either way you want to do it. I'm going to do A is the high byte, A plus 1 is the low byte. Move 0 to A, move 3 to A plus 1. I now want to take B, add it to the result. So take B plus 1, add it to W, or add it to A plus 1, put the result in A plus 1. Now, take B, add it with A, but now I add with a carry. In case there was a carry in the first operation. Gives you B plus 3. Now add in C. Add the low byte, add the high byte with carry, add C again, low byte, high byte with a carry, gives you 2 times C. Other ways of doing it, this works. And you now have that function. And kind of things to note, a 16-bit operation is much harder than 8-bit operation. Floating point is much, much, much harder than 8-bit operations. You can do it, but it can take a lot of code. And this is kind of one reason we like C over assembly. The C code is much, much easier to understand than assembly. Same thing though. Problem 4 is an if statement. So if I want to compare a byte, 8 bits, I use the CPF. And to figure out how to use that, I look at the data sheets to see what I'm comparing. So CPFSGTA is going to skip if A is greater than W. So we'll do A greater than B. To set it up, I first have to move B to W. Now skip if A is greater than W, meaning A is greater than B. So if I skip, I go down here. If I don't skip, then I want to do the else statement, or skip out. So go to label 1. If I do skip, I want to increment C by 1. Then do the second if statement. If A is less than B, decrement C. So I'm going to use the compare skip if less than. I need to set it up, so this is going to be A less than W. I first have to set up W as B, so move B to W. Compare skip if less than A. If A is less than W, skip. That's the decrement. If I don't skip, then I jump to the end, and thus purpose but no op gives you something to put a label. Problem 5. Convert a flowchart to a program. And here every block gets converted. Let's get this out of the way. So starting out, this is the initialize. You actually need another one. This one actually run. I need to move, let's do this one. MOV LW, OX, OF, MOV WF, AD con 1. You need to add these 2 lines of code as well to get it to work. The reason being is the default on the PIC is analog. If we need something other than analog, I've got to change the default. That's what this does. Changes it to binary. In addition, there's a bootloader on our chips. The bootloader takes up the low 800 spots of memory, so this does an offset, so my code loads at 800. But ignoring that, first section of code, for input, I move the number FF to tris-B. 1 is input, 0 is output. Move all zeros to tris-C to make port C output. Next section of code. I'm going to keep on looping as long as port B bit 0 is equal to 1. That's the bit test, skip if clear. If it's a set or a 1, I don't skip, I keep on looping. As soon as it goes low, I skip out and go to label 2. In label 2, keep looping as long as port B bit 0 is not 1, meaning 0. So I'm going to skip if set. If it's 0, I don't skip, I keep looping. That's this section of code. Now this one gets more complicated. On a 1, 0, I want to go to label 4. It's going to check bit number 2, the least significant bit. If it's a 1, I go down here. If it's a 0, I don't skip. I'm then going to check the next bit. If it is a 1, I don't skip, go to label 5. Otherwise, I go to label 1, which is down here, label 1. Label 3A. If this one failed, I have a 1. Skip if clear. If it's a 1, I have a 1, 1. On a 1, 1, I go to label 6. Otherwise, I go to label 4. So in label 4, I want to set all bits on port C. Move FF to W, W to port C, go to label 1. On label 5, I'm going to clear port C, go to label 1, label 6. I toggle all bits. That's the assembler command complement. Go to label 1. So this is the code that matches that flowchart. And finally, this is rolling a 6, 8, or 16-sided die. This section of code is your initialize. I'll put all 1s in tris-B for input, all 0s on tris-C for output. I'm going to check is port B equal to 0. So this is a bit test. This is a byte test. I'm going to check all 8 bits on port B. So to do that, I'm going to use the CPFSEQ. I'm going to move 0 to W, compare port B to W. Is B equal to 0? If so, skip. If it is equal to 0, jump back to label 2, skip. Otherwise, go to label 3. Label 3. I want to know which button was pushed. This is a bit test. I'm going to check if button 0 was pushed, go to label 4. So if it's 1, I don't skip, go to label 4. If bit 1 is pushed, go to label 5. Bit test, skip if clear. If it's set, I don't skip, go to label 5. Otherwise, go to label 6. Label 4, I count mod 6. So one way to do that is if I'm equal to 5, move 5 to W, compare if equal. If it is equal to 5, I'm going to clear. So 5 plus 1 becomes 6. Mod 6 is 0. Otherwise, go to label 4A. If it's not 5, I just increment. Go to label 7. And 7's down here. Label 5, increment mod 8. I just increment and 7. Powers of 2 are actually easier to do mods, so if you just do and 7, that clears out all bits except the last 3, that's mod 7. Move to port C, go to 7. Mod 16, and with 15 gives you mod 16. Move to port C, jump to 7, label 7. This is another compare skip if equal. Move 0 to W, compare B to W. If it is equal to 0, then I go to label 2. If it's not equal to 0, I go to label 3. So that's homework set number 2 for ECE 376.